Hello honors chemistry students, this is Mr. Spurk and this is your chapter 2 section 1 notes on the properties of matter. So we're going to talk about describing matter. There are two types of properties to describe matter. There are extensive properties, which depend on the amount of matter of a substance. So for example, mass and volume. So again, these are about the amount. As the amount of something goes up, its mass and its volume increase. Then there are intensive properties. Intensive properties do not depend on the amount of matter, but the type of matter. So some intensive properties are things like odor, color, and absorbency. So think about a crayon. If I have one red crayon, it is pretty red. And if I have 10 red crayons, they are still that red. So a substance is a matter that has a uniform and definite composition. Remember that uniform means the same throughout, and definite composition means that it is always made up of the same thing. So every sample of a given substance has identical intensive properties because every sample has the same composition. So let's talk about physical properties. A physical property is a quality or condition of a substance that can be observed or measured without changing the substance's composition. So for example, we look at hardness, color, conductivity, which means it can conduct heat or electricity, malleability, which is its ability to change shape, the melting point, and the boiling point. So all of these qualities can be observed or measured without changing the substance's composition. Physical properties can help us identify substances, and we will do this throughout the year, and you do this all the time in your day-to-day life. So substances that are similar typically will have at least one physical property that will make them different. So for example, all crayons are made of the same wax material. They all have the same chemical makeup, same composition. They just are only different based on their color. So color is something that is extremely important for us to be able to tell the difference between. So we're also going to talk about states of matter. The first state of matter we're going to talk about is a solid, which is denoted by a lowercase letter s. Solids have definite shape that does not depend on the container. So no matter what container you put it in, its shape does not change. They have a definite volume. Their particles are packed closely and they are arranged orderly, as you can see from the particle diagram in the bottom right-hand corner. Solids are very ordered. They are incompressible, which means that we cannot squish them, and they expand slightly when they are heated. And they have vibrational motion, which tells us that they have low kinetic energy. So if you look at the particles, you can see these little black lines in the area. That means that they are wiggling or vibrating. So the particles that make up your desk, your pencil, your phone, those are made of tiny little particles that are vibrating. So they are moving on the atomic level. The next state of matter is a liquid, which we denote with a cursive L, or AQ. Now AQ means aqueous, which just means that something is dissolved in water. This is a term that we will define in our next in our next unit, and we will pay close attention to aqueous solutions. So liquids have indefinite shape, which means that they can change. They take the shape of whatever container they're in. So if we take water and put it in a beaker, and then take that water and pour it into a vase, and then pour that into a bottle, it's going to take on the shape of whatever container it's in. Liquids have a definite volume. Their particles are close, but they can slide past each other, so they're not rigid. So if you look in the particle diagram over here, you can see that their particles can move past one another or slide around. So that sliding tells us that they have a moderate kinetic energy and that they can flow. Kind of went a little bit out of order there, but they can flow past one another. They can expand slightly when they're heated. And since they flow and can slide past one another, they have moderate kinetic energy. So again, I always just think about liquids being in the bottom of a cup or in the bottom of a container, and you can swish them around. They can flow past one another. The next state of matter we're going to discuss is gases, and we denote that by a lowercase g. Gases have indefinite shape, and they take on the shape of whatever container that they're in. So I always think about our classroom. The gas fills and expands to the entire classroom. So they also have indefinite volume. But when we're talking about shape, we want to think about something like a balloon. If you blow air into a balloon, it's going to blow up into a round shape because balloons are made to be round. If we blow that same gas into a longer balloon that's going to be used for a balloon animal, it comes out in that long stretched out shape. Then if we bend that balloon and twist it into a giraffe or a dog, that gas is now in that shape. So it takes the shape of whatever container it's in. Gases are easily compressed. So again, think of a balloon. You can squish a balloon pretty easily. And they move in constant rapid, random, and straight line motion. So again, look over here at the particle diagram. These guys are in a rigid container, and they're just going to bounce around in straight lines off the corners, off the sides of the container. They are not traveling in a squiggly pattern. They only travel in a straight line pattern very rapidly. So they have very high kinetic energy. So the term gas refers to the state of matter at room temperature. So for example, oxygen is a gas at room temperature, so that's why we call it oxygen gas. But the term vapor refers to a solid or a liquid at room temperature, but when it's heated, it becomes a gas. So again, if you think about boiling a pot of water and you see that steam rising above, we don't look at that and say, hey, look, that's water gas. It's water vapor. So a vapor is what is produced when a solid or a liquid at room temperature turns into a gaseous state. So another state of matter you may have heard of is plasma. This is sort of related to plasma TVs. They are a very high energy state that conducts electricity. They're composed of a mixture of ions, electrons, and neutral atoms. They are group 1 elements that usually form plasmas. So that's that very far left column on the periodic table. And they exist at very high temperatures. The last state of matter we're going to discuss, and this one is not so important to us, but I would like you to know about it. They're called Bose-Einstein Condensates. You may have never heard of this term, and that's all right. They were only discovered and they emerged in 1995. It is a superfluid that exists at almost 0 Kelvin. So Kelvin is a temperature scale, and 0 Kelvin is the coldest temperature that can possibly be reached in the entire universe. That is when there is absolutely no vibrational motion among atoms. So technically, we can never reach absolute zero or 0 Kelvin. But when these particles are down at that temperature, they behave like waves. So they no longer travel in straight line patterns like they do here. They travel in a wave-like motion. And they display a lot of unique and bizarre characteristics. All right, back to physical changes. Some properties of the material change, but the composition of the material does not change. So that's one of the most important parts of physical changes. We aren't changing the chemical makeup or the composition, but we are just changing what it looks like. So no new substance is created. So words to look for here are words like boil, freeze, melt, break, split, grind, cut, or crush. So think about a piece of paper. If I split a piece of paper in half, it is still paper. I have not changed what that paper is made of. That's a physical change. When water boils, it goes from a liquid to a vapor. It is still H2O. So physical changes can be reversible. So if you think about an ice cube, it can go from a solid, we can melt it to a liquid, and then we can freeze it again back to a solid. And they can also be irreversible. So think about breaking something into pieces. If you drop a beaker, like in class perhaps, it's going to break into a bunch of pieces, and it's pretty difficult to put that back together, if at all possible. Another good example is if we do a medicine lab, we will take acetaminophen tablets and we will crush them up. We turn them into a powder, and that is irreversible. We will not be able to put them back into their pill form. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a great day.